Hello everyone, the Instant Camera Guy here, and welcome to another Polaroid SLR690 video. Now, for those that have been following my channel, you should know that I did 3 videos which are a very deep dive into the Polaroid SLR690 and the baffling design flaw within its electronics. So far I've done a video explaining that the 690 electronics were complete garbage, to which I got a few salty replies from what I assume must be people that own Polaroid SLR690s. I did a video where I took it apart, and then I did a final part to that video where I actually modified a client's SLR690 to become an SX70 Sonar with one of the modern Bluetooth PCBs so that it could have manual control. Well, this camera here, a bit of a spoiler alert because I planned on releasing this in a few weeks. I'm just waiting on parts to finish it off. But I've effectively combined a Polaroid SX70 Model 1, the front housing of a sonar, the door from a sonar, and the shutter, flash mechanism, and body ribbons of an SLR690 to form a chrome SLR690. And what I've done in order to mitigate the problem with the electronic design is I've removed the battery terminals completely, and I plan on wiring this thing up into one of those retrospect AAA battery holders. And the reason that that's going to be a good idea is it's going to fix the main design flaw in the SLR690, which is that in the SLR690, which uses a NEC microcontroller and transistor arrays to control the various functions of the camera, the PCB in the shutter stays constantly powered on, even when you close the camera. So even when the camera is collapsed, provided that there is a pack of film in there with batteries, that PCB stays turned on, and eventually that constant standby load on the chips causes them to blow, which will brick the camera. So by removing the original battery terminals and hardwiring in a set of AAAs using one of this is the prototype version I got sent when they were still testing it, but using one of these retrospect PolarPack battery adapters, we're going to be able to run that off AAAs and most importantly have a switch that we can kill the power whenever we please. And that should drastically prolong the life of this camera. So I'm getting too far into this. What I wanted to do, because I've had the opportunity to build this, I actually wanted to show you how it's such an issue, because I've got it open here and we can actually trace where the negative goes from the batteries and see what the difference is. So first of all, let's start with some SX70s. So I have 2 chassis here, both taken from SX70 Model 3s. So thank you to any of you watching who donated. And basically we've got 2 flavors. The first is what I call a Model 1 ribbon circuit. This is the main type of ribbon circuit found on SX70 Model 1, some very early Model 2s, but mainly SX70 Model 1s. It is made of a material called Kapton, which is kind of this brown plastic stuff. Over here we have a later version of the PCB, which uses a waxed paper. So this is a very similar to design to what they would later use in Alpha and Sonar cameras. The main difference is Alpha cameras had a tripod socket right here, so they kind of changed the shape of the ribbon just to move around that. But for all intents and purposes, they are the same. So let's have a look at the SX70 Model 1. The positive terminal is here. It's the one on the left. And one of the traces goes to the film counter at the back. The other trace goes to the side of the body, and that then travels into the shutter. So that provides positive power. The negative terminal, if we follow it, goes over here to the door switch. Now, the way that this works is if you have a door in the camera, when you open the door, it opens the switch and it cuts the circuit, so no power can flow. So first step in a Model 1, if that door is open, no power can get through because the negative connection is cut. Make sense? So when you close the door, that completes that connection, and now we can continue following the trace. We follow it all the way down the side to the rear hinge switch. The rear hinge switch, when you erect the camera, pulls a little metal tab into place, and that completes the next part of the circuit. So basically, if the camera is collapsed, that connection is cut. No negative connection because the switch completely cuts it. But if you erect the camera, then it can complete the circuit. It jumps over this little bridge, down to the side, and then forms the negative on the body ribbon. That goes to the shutter. And so what that means is if you collapse the camera or you open the film door, power to the PCB is completely cut. That saves the battery and it prevents putting load on the electronics. So that's how the Model 1 works. The Model 2, Alpha, and Sonar, very, very similar, but they redesigned the PCB so you didn't need this little bridging part here. And it's the same principle, but it works in reverse. So if we start on the negative trace here, and we follow that, it goes now to the back, to the hinge switch, through the hinge switch, to the door switch, and the door switch now jumps around the top. So it's got this extra little loop here that the Model 1 doesn't have. So by basically adding this little loop, they negated the need for having this little jumper pad here. So that would have saved quite a bit in production because this is an extra step, basically. You have to put the ribbon cables down, solder on the jumper, then put capped on. This eliminated 2 points of solder, basically. So it's the same principle, though. It just works in reverse. If you collapse the camera, it cuts this power switch. If you open the door, it cuts this power switch. Ultimately, a great design. It basically means when the door is open or the camera's collapsed, no power goes to any of the circuits whatsoever. The battery supply is completely cut from any electronics in the camera. Really good design. Let's compare to this. You ready? Positive is very similar. It goes straight to the side body ribbon and into the shutter. That's fine. That's how the usual SX70 works. The other component goes to the film counter. Again, very similar to the SX70. But let's follow the negative trace. It goes to the back but stops here, so that goes nowhere. So if we follow it to the front, you think, oh, it's going to the door switch. But it doesn't. If you look very closely, see if I can get the camera to focus, it actually goes around the door switch, straight into the ribbon circuitry, into the brains of the camera. What the heck? It bypasses everything. And so that means the door and the hinge switch, they don't actually cut any power. They simply send signals to the brains of the camera that tell the camera, do not function. This is the equivalent of buying a car where you can never turn the engine off. And when you turn the ignition off, it doesn't actually cut power to the engine. It simply just engages a clutch, which means that you can't drive the car. That is the best analogy I can come up with how this thing works. So effectively, the brains of this camera are continuously powered 24/7, provided you have film in there. And the switches, which were initially designed to cut power, now simply just function as telling the computer what to do. This design choice is baffling. I cannot think of any reason you would want to do that. Because typically when you have standby power in an electronic device, it's really only for one of two reasons. The first reason is that perhaps the electronic device takes some time to power up or boot, right? Think about it like a computer, turning it completely off versus putting it to sleep. If you keep it in that kind of low power mode where everything's just on standby, it's going to start up a lot quicker. So that's one reason that you may want to keep the brains completely powered. But I just don't buy that in this case because like the SX70 is designed when you erect it, boom, it's good to go. So I don't think that's the reason that they designed it like this. The second reason that I can come up with for maybe wanting to keep power pretty constant is that perhaps at some stage there was something else planned for the 690 that never came into fruition. So for example, maybe they were gonna add extra features but ran out of money or time and effort or something like that. Because if you keep the power constant, then you could do things like add a calendar or a date. So maybe an original plan was, instead of this mechanical film counter, maybe they were going to do it more like what you find on the 1600 and have a little liquid crystal display. That's how the counter on this thing works. It's not mechanical at all. It's completely electronic. So maybe there was going to be some kind of little liquid crystal display where it would read out information. Like, I don't know. That's the only thing that I can think of that would necessitate a design like that, where the power was completely constant. I can't really, and please feel free to guess in the comments below why the engineers for Polaroid Japan designed it in this way. Because effectively what they did is they really drained the life out of all the electronics in the 690 by having that constant standby power. And there doesn't seem to be any advantage that I can see, that I can think of at all. Why they didn't just go with the standard Polaroid design that cuts power is completely beyond me. So yeah, I'm going to leave it up to you guys. What do you think? Do you think that there were more plans for the 690? Were they going to have like a calendar or a clock or a liquid crystal display, something to retain memory or settings? Was the light dark wheel initially going to be some kind of like, I don't know, exposure buttons or something like that? It's like they designed the circuitry to have extra features that were never used. But yeah, I think that's really all I wanted to say. As I said, I will do another video on this camera because I have purchased one of the Chrome versions of these from Retrospect that I will be installing into this. I'm going to bypass the little pogo terminals and I'm going to directly wire it into the camera so that you get a 690 with an on-off switch. I fully repaired this. It's got new ribbon cables. So this thing is going to be a great camera when it's finished and when it's got that battery compartment. And I think I want to stress by saying the 690 is not inherently bad. It works really well. It's got really strong motors, great autofocus. The exposure system is dead on. But that weird design choice to constantly power the PCB and building the camera with very flimsy ribbon cables that tend to break and lose connection over time, just brick these things. Like, the way that I've rebuilt it here is probably the best solution that I could possibly come up with to making this a reliable camera again. Because once you remove that constant source of power, the reliability is going to go up by a multitude of factors because of that battery drain. So yeah, I just wanted to really dive in and show you guys where these traces go, because I can't understand why anyone would engineer it like this. So I'm actually kind of, yeah, just going to leave it here. Leave your comments below. What do you think? Why did Polaroid do this? It's really strange. As always, thank you for watching. I'd like to give a huge shout out. Let me just pull up my little Ko-fi account here, because a whole bunch of you supported me using the links below on my Ko-fi account. So massive shout out to Dylan Canfield, to Robin, Rob Vandergaard, and Noah, who all bought me a beer over the last month or so. I've been meaning to give you guys a shout out, but I've just totally forgotten. And yeah, a huge thanks to everyone that watches my channel and supports me and likes what I've been doing. If you want to support me, as I said, links are below, or simply send me something to repair. You've been a wonderful audience, as always. This has been part 4 of the 690 saga. There will be a part 5 where I wire in that new battery back. But yeah, I just wanted to show you guys the traces because I've been doing so much research wiring in my battery solutions that I've come up with recently. that I really wanted to make it clear. So yeah, if you ever had any doubts, maybe you thought I was making it up that these that these are not designed right. Well, the proof is in the pudding. Just open one up for yourself and tone out where those bits go. Anyway, I love you all. I'll see you next time, and happy shooting.